In a similar fashion to the useMemo hook, useCallback gives us a means to optimize our application somewhat. It also provides a form of memoization. However, the big difference between the two hooks is that useMemo provides a way to memoize a value, whilst useCallback memoizes a function. It looks and feels almost identical to the implementation of useMemo 2. You define and use useCallback hook like this. Great, you're thinking, but why would anyone want to memoize a callback function? Well, the complicated answer is, it depends. Let's start with a little 101 on React components. Each time a component re-renders, React will create a new version of items like function objects. Take the following code snippet as an example. Each time my Epic component re-renders, the handle button click is recreated as a brand new function object. For most components, this isn't a problem and usually nothing that you need to concern yourself with. This recreating of functions is inexpensive and not going to cause you any problems, performance-based or otherwise. However, there are some situations you might face when you don't want this behavior. One such example might be when the function is a dependency of other hooks. In this situation, you'd want to have access to the same function object across different renderings and not a brand new instance, or we'd be back to the infinite looping territory again. When it comes to the useCallback hook, in essence, given the same dependency values, useCallback returns the same function instance between re-renders. The useCallback hook is one of those tools that you may or may not come across a great deal, but when you do need to use it, the benefits are great. However, because of the rather infrequent need to use this hook, our example is going to be a little more contrived to highlight those benefits. We'll be building a message generator and some buttons that increment counters within the component. We'll keep track of the functions that our component recreates across each re-render so you can see how useCallback comes into play. Let's start by opening the useCallback example.jsx file and building it out. So, first things first, we'll need to import React, useState, and of course the useCallback hook. Next, we'll need a couple of constants that will live outside of our main component. We have a simple array of string messages that we'll use within our component, and with function store, we're creating a shiny new instance of a set object. You can store lists or collections of anything you like in a set object, but the key part here is that set naturally keeps things unique for us. The importance of this will become apparent in a little while. Next, let's create the default export component. Let's outline a couple of variables at the top of our new component. We've got two state variables, counter and message. Our counter variable will hold the current count as we increase it, and while message will hold the currently selected message from our previously defined array of message strings. Now for the useCallback part. We'll create three click handling functions here, one to increase the count, another to decrease it, and a last one to generate a new message. Each will update one of the state variables we just created. Both increase counter and decrease counter implement the useCallback hook using the counter variable as a dependency. Remember, each time a dependency changes, useCallback will generate a new callback function object for us. Both these functions update the count value in state, either by adding one or removing one. The generate random message function depends on the message state variable and updates this message in state, pulling a random string from our messages array. The very last thing we'd like to do here before moving on with the JSX is to add these new functions into the function store, like so. Now, each time our component re-renders, it will attempt to add each of our three click handler functions into the function store set. If one of the function objects already exists within the set, it won't be added. Later on, we'll extract the number of functions in the set to see how many new function objects have been created on each re-render. With our logic in place, all that remains is to outline the JSX for our UI. We're starting off by outputting the current count using the count value from state. Next, we do the same but for message using the double pipe operator shortcut to display an instructional string should message be empty. Next, we have three buttons that we're attaching to our click handlers, one to increase the counter, one to decrease it, and a final one to trigger a message generation. The final piece of the JSX puzzle is to output a simple message to the user showing the number of items in the function store set. To do that, we call sets.size property, which is equivalent to an arrays.length property. So you can see what we've got is quite simple. The current count is 0 when we have no message set and our buttons are ready to be clicked. But take a look at the line under the HR element that counts the number of functions the component has created. You can see that our 3 click handler functions have been created and added into the set, so the size of the set is naturally 3. So what happens if we click one of the buttons? Let's click Generate Message to choose a random value from the messages array. Notice that even though the component has re-rendered, only one additional function has been created. In this case, it was the Generate Random Message click handler function, and that's because its value in state, i.e. the message, changed. This state value is passed as a dependency to the useCallback hook, hence the function is recreated. This time, let's click on the counter plus and see what happens. Notice that this time, the size of the function star jumps up from 4 to 6. On this re-render, Generate Random Message is kept the same because we haven't changed its dependency, message. However, we've altered the count state variable, which both increase counter and decrease counter depend on. Therefore, both of these functions have been re-rendered and recreated on this particular rendering. But what happens without useCallback? To drive the point home about the effects of useCallback, let's make a couple of changes to the component. Back in the component file, find our click handling trio of functions and remove the useCallback hooks. So all we've done is removed the useCallback hooks wrapper and the dependency array on the other end, leaving us with standard arrow functions. Refresh the browser and let's go through our button clicks once more. Notice this time that no matter what we click, the size of function star increases by 3 each time. Because our click handling functions are no longer memoized via the useCallback hook, each time the component re-renders, a brand new version of them is created and added into the set object. As you can see, this has almost zero impact on the running app, and our users will be none the wiser for our changes either way. However, it illustrates quite nicely exactly how the useCallback hook works.
If you want to keep learning about how to build real-world apps with the latest technologies and other career-related topics, then start right now by subscribing to our channel and liking this video.